Okay, in this tutorial we're going to discuss load cases and how we work with load cases and how we can create multiple load cases and what they really mean. So I'm going to go ahead and open up a tutorial that I've simply put together. It's a coal conveyor, 2,500 tons per hour. And if we look at the profile of this conveyor, it's got a flat section followed by a decline section, another flat section, followed by an incline section, and another flat section here. So this is a fairly complex conveyor profile here, but I'm using it to demonstrate how we use different load cases. Now if I go up to our project information, you can see by default we will always have a empty and a fully loaded normal friction case. Those two cases are by default what we will always have. So when I run the calculations, we can see that we've got an empty case and the fully loaded. The empty case happens to be pulling about 108 kilowatts of power. The fully loaded case is pulling 358 kilowatts. And Sidewinder, we haven't specified a nameplate rating, and the Sidewinder just picked a 400 kilowatt motor. Now we need to be careful on conveyors like this because the fully loaded case doesn't tell the whole story. Obviously we can see as the conveyor loads, it could load just this section and we would have just a decline section, or a flat and a decline section of the conveyor loaded. Likewise, when the conveyor is unloading, the conveyor would become empty, and eventually it would get to a situation that only this flat and the incline sections are loaded, or incline section is loaded. So these two load cases are very important, and we need to look at more than just the empty or the full case on this conveyor. So if I go back to our project information here, I could select the very next option, which is inclines and declines. And what that does is that creates another case that simply loads all the inclines and the flat sections under high friction, and it also creates another case with just the declines loaded under low frictional conditions. Okay, so if I now go ahead and run the calculations, we can see that we now have 4 load cases here. We've got our empty, our fully loaded, the inclines, the flats and the inclines loaded, and just the declines loaded. And if I go ahead and look at the case, we can see that for the decline load case, we're actually 45 kilowatts in regeneration. In other words, if the conveyor goes to stop in this mode, it's either going to drift for quite a while. The conveyor might run away from us, so we're going to need to perhaps put brakes on this conveyor or do something special with this conveyor to keep that load from the conveyor from running away from us in case we happen to lose power in this situation. Likewise, our inclines, if we have just the inclines or the flats in the inclines loaded under high friction, our demand power is now 502 kilowatts. And now Sidewinder actually picks a 560 kilowatt drive. So again, it's important to look at these different load cases. Another case that we haven't looked at, or that hasn't been included, is what happens if we load just the incline, but we do it under low friction. And why would we want to load just the incline section under low friction conditions? Well, in this case, we probably are going to have a backstop or some kind of a backstop up at the head to hold this conveyor from running backwards in the event of stopping this conveyor or a power failure in this condition. So in that case, we actually want to say, okay, what's the maximum backstop rating that we need? So in that case, we'd want to load just the inclines, but under a low friction condition. So when I go over to our load conditions here, we can create a custom case, and we can still keep our incline and flat, but we can also now create another case, say inclines only, and we'll say low friction. And again, the frictional condition is related to this frictional condition page. These go hand in hand. The nominal friction is our expected operating conditions, our expected idle or drag, our expecting rolling resistance, so on and so forth. It's at our specified ambient temperature here. However, obviously in winter time, we're going to want to see what the highest friction of the conveyor would be, i.e. in wintertime the lowest temperature. We also might increase our idler drag in case the idlers that we get have a higher drag than what we anticipate. Might decrease the mechanical efficiency. Perhaps we add a little bit to the top and bottom belt covers due to manufacturing tolerances and so on and so forth. So we can add all those for a high friction case. On the opposite side, our low friction case, we'd have our highest temperature. We'd reduce our idler drag, reduce our accessory losses, increase our mechanical efficiency, so on and so forth. So if we go ahead and run this case, and now we have just the inclines loaded. And again, as I had said, that might have, I kind of knew that would have something to do with our backstops. But if I look at my backstops, the all inclines and flat under high friction has a lift force of 47 kilonewtons roughly. And if we take that lift and subtract half of the drag, which is just sort of a rule of thumb for sizing your backstop or whether you need your backstop, need a backstop on the conveyor or not, we can see the lift minus half the drag is 24 kilonewtons. However, if we only load that incline and we use low friction, it's 34 kilonewtons. So obviously that is our worst case scenario, and we can see here, hey, a backstop, none are installed but are required. So it's important to look at some of these other loading cases. Again, if I go back to the project information, if I right click, and I'll do that up here so you can kind of see the window, there's a number of different built-in scenarios in Sidewinders. Inclines only, inclines and flats, the largest incline. Maybe you've got a complex overland conveyor and you just want to load rather than loading every single incline, we just want the two largest inclines. Or load the whole conveyor except for the largest decline. Likewise with the declines, there's a number of options. Loading on and off. We can load on to the maximum point, perhaps load off, load on to the minimum point. These are all just different load cases. And a lot of times, especially on long overland conveyors, it might not be obvious what are the worst case conditions. So you may have to look at several of these, run the calculations, and then from there you can go ahead and say, okay, well, look, this case is worse than that case, or so on and so forth. Maybe if you load all the inclines, you might have 8 inclines loaded. Well, that might not be a realistic case. Maybe you only want to load 3 of those inclines or whatnot. But there's quite a number of different options, and I think we cover pretty much all of the main options. A reversible conveyor, if you happen to have a reversible conveyor, load just a reversible side or incline, so on and so forth. But we also have custom cases. Custom cases essentially allow us, and I'll just create a custom case here. Custom cases are if none of those happen to fit in for your specific conveyor, you can go ahead and create a custom case and load it however you want. And we do that by simply clicking custom, selecting whatever frictional condition we may like. And when we go we can go to our geometry. Normally we're always working in this vertical profile, but we can also, in the conveyor profile, that we normally don't change things, we can see here's our built-in cases, inclines and flats, declines, but here's our custom case. And that's in black rather than this grayed out that we can't change these variables. But in the black column, we can go ahead and make this condition whatever we want to make it. So we can make a custom case, or we could even load partially loaded. I could load those elements by 50% or 10% or whatever. So if there's some strange condition that you want to look at, you most certainly can always create a custom case and go ahead and run that. And we'll see now we have a custom case with this special loading that we specified. So that's pretty much how we use this load condition. Another option of something we might do is we might say, okay, let's have a fully loaded conveyor, but perhaps we're going to increase the tonnage by 20%. So what happens in that situation? So I can go ahead and say, okay, let's load the conveyor fully loaded, but let's say it happens to be overloaded by 20%. Or maybe we even want to do a incline case and overload that by 20% just to be extra safe. So I can go ahead and run those calculations, and we can see, okay, now if we have only the inclines loaded, and in this case our design tonnage was 2,500, but we upped that by, what did I just say, 20%, which is 3,000 tons per hour. So in that case, with the inclines loaded, inclines only, at 3,000 tons per hour, the actual power consumption is 490 kilowatts. So we can look at all these additional cases that may be of interest to us, and we don't have to create and save and work with multiple files. We can simply have one Sidewinder file, but with all these different conditions. Likewise, if we have multiple materials, we could go ahead and specify a different material set. Maybe we've got a second material, or we're running different materials on the belt. Perhaps we're going to use a different belt speed. So in catch-up time, we're going to run 120%, but we're going to increase this belt speed from 5 meters per second to 6 meters per second. Let's just go ahead and remove this, remove that locate. So now we'll be running at 120%, or I could actually just type in 3,000 tons per hour there as well. I can either specify that as a value or as a multiplier. When I go ahead and run that, we can see now for that case, we're now running 3,000 tons per hour and 6 meters per second, and the power consumption is 442 kilowatts, versus our full normal case was 2,500 tons per hour at 5 meters per second. So that's essentially our load conditions. We can specify a few other things. If we want to include pullout forces, we'll talk about that in a later tutorial, but that's essentially if the feeding conveyor, if you have a power outage and the conveyor that's feeding this conveyor happens to plug up your chute, this specific load case, by specifying 1 or 2 or whichever feed point I want to include those pull-out forces, it would include those forces when starting up the conveyor, so you get some additional drag forces there. If it's a reversible conveyor, and this is our design level. In Sidewinder, it lets you use design levels 1 and design level 2. Design level 1s are cases that happen all the time, and on a conveyor like this, if we look, every time this conveyor unloads or loads on, you're always going to have this decline section loaded, and every single time it unloads, you're going to have this incline section loaded. So those are pretty common occurrences. So those you actually might want to specify as design level 1s. Cases that are maybe not quite so common, you could specify as design level 2s. And what that essentially boils down to, and you might want to read through the manual in here, but design level 1s and design level 2 allow slightly different belt safety factors. They have a slightly different allowable edge stresses and so on and so forth. So the program will highlight problem areas slightly different, which makes total sense. If you have a long overland conveyor that maybe potentially could have 3 incline sections, you need to design for that case, but certainly that won't happen on a daily basis. So a case like that would be a design level 2, versus your load on, load off conditions. Those happen all the time, so those typically are design level 1s. So that's something that you just kind of have to use your engineering sense for and go from there. Okay, I think that pretty much wraps up the load conditions, and we'll continue on with the next tutorial.